Hi, my name is Aurora Lang from Danville, California. Welcome to Aurora Tech Channel. Today I received my 5th 3D printer, the Sovol SV01. It's my first printer in 2021. My mom always asks why my brother and I want so many different kinds of the same thing. Well, we have a Creality Ender 3, an Alfawise U30 Pro. I also have a Creality CR10S Pro V2. And an Anycubic Photon Mono resin printer. But we don't have any direct drive printer, which can print flexible filament like TPU. Previously, we tried to mod the Alfawise U30 Pro to a direct drive printer. As you can see, this printer has been heavily modded. We upgraded it with a Micro Swiss all-metal hot end, a dual gear extruder, we added an X-axis and Y-axis belt tensioner, and replaced the stock 8-bit motherboard with a BIQU Tech SKR E3 Mini 2. The stock screen has also been replaced with this 3.5-inch TFT touchscreen, a Raspberry Pi 4 with Octoprint, another 3.5-inch TFT touchscreen for the Pi, and the BL touch sensor for auto bed leveling. The print surface has been upgraded to a Creality Ultra Base glass bed. I stuck a PEI print surface on the other side, and finally, a much more reliable filament sensor. We actually spent $360 to upgrade this $180 printer, and it works great. The print quality is almost the same as the CR10S Pro. Unfortunately, we weren't quite as successful with the direct drive upgrade. It still prints pretty good, but it just doesn't print as well as the Bowden tube setup. The reason is because this Alfawise U30 Pro is actually very similar to an Ender 3 or Ender 3 Pro. They are both single Z-axis printers. That means the height of the gantry is controlled by only one stepper motor and one lead screw. For the direct drive extruder upgrade, you need to put the stepper motor and the extruder on the X-axis. It becomes heavier than the stock setup. It actually drops a little and affects the print quality. You may not notice that if you just print a small object in the middle of the bed, but it can become obvious if you print a flat, large object that occupies the whole print bed. For example, this Sudoku game board I made for my grandpa, or printing a lot of small parts that uses up the whole build plate. The nozzle drops too close to the bed on this side. It's hard to get the perfect first layer with this setup. But why don't we just change the CR10S Pro V2 to a direct drive? Well, the answer is it prints so good out of the box, even with the Bowden tube system, stock extruder, and hot end. We don't want to change that, so we always have a reliable, high-quality printer when we need to print something nicely. So with all these reasons, we decided to buy another 3D printer. It must have a direct drive extruder, it must have dual Z-axis, auto bed leveling is preferred, larger print volume is also preferred, and our budget is around $300 to $400. We compared a few options, including the BIQU. This printer is from BIQU Tech. I like their 3D printer control board. As I have installed their 32-bit board and touchscreen to the Alfawise U30 Pro, it works really well. It has a print volume of 250 by 250 by 250, which is slightly larger than a regular basic model like Ender 3. It comes with a dual Z-axis system, a lightweight direct drive extruder, and a 7-inch touchscreen. It also included an inductive sensor for auto bed leveling. It may not work as well as a BL Touch, since it only works on a metal print surface and not a glass print bed. This printer was on a Kickstarter back in October 2020. The Kickstarter price was only $309. Unfortunately, I missed the Kickstarter offer. If the price of this printer is under $350, I think it's still a pretty good deal. However, it seems this printer is currently out of stock or unavailable for some reason on their official website. The special price has also increased from $500 to $549. I'm not really sure if this is a typo. If it costs $500 or more based on this configuration, it's not a very appealing deal anymore, so I will consider other printers. We have also considered the Artillery Sidewinder X1. This printer has a large 300 by 300 by 400 print volume, direct drive extruder, and dual Z-axis. It also has a color touchscreen. It also costs $400. Adding a BL Touch will cost around $450. Finally, we found this Sovol SV01, which has direct drive and dual Z-axis. It also has a slightly larger print volume, 280 by 240 by 300, just in between the Sidewinder X1 and BIQU BX. It only cost around $250. With the BL Touch upgrade, it would be $290. It's on the low side of our budget, but the downside is this printer doesn't come with a TFT touchscreen, but we're okay with the classic Marlin LCD screen. Moreover, we use Octoprint to control all our printers over the Wi-Fi network most of the time. If we need to change some settings like the Z offset and E step settings, we can always use Octoprint web interface or the terminal inside Octoprint to do that, which is very handy. It also just comes with a noisy 8-bit board, which is a Creality board. I know how noisy it is, as the old Ender 3 also came with the same board. As long as you aren't putting it in your bedroom, I think it should be fine. We can easily add a 32-bit silence board in the future. So we decided to give it a try, and here it is. Let's start unboxing and see what's inside. Whee! Alright, let's see if we're missing anything. Here we have the gantry, the base, the display screen, all of the other tools, the filament holder, and 200 grams of filament. This printer is pretty much pre-assembled. The top part, including the extruder, wheel, the X-axis, and the whole Z-axis with motors, are pre-assembled. The bottom part, the Y-axis, the belt, heated bed, everything is pre-assembled. All I have to do is connect the gantry, the base, the spool holder, the Z-limit switch, the filament sensor, and the LCD screen. I also ordered the BL Touch, but it wasn't included in this box. I think they will mail a BL Touch in a separate package. I expect the BL Touch should be installed or at least come with the same package, but it seems that's not the case. But that's no big deal. I will just assemble it without the BL Touch and see how well it can print. Since I have some experience assembling other 3D printers, I think this can be done in about 20 minutes. First, I would suggest checking the voltage of the power supply. Many other countries use 220, but here in the US, we use 110, so let's make sure we set it correctly. The screws of this machine are very simple. The 4 longest M5 by 25 screws are for the gantry and base. These 2 second longest M5 by 20 screws are for the screen. These 2 sets of screws and T-nuts are for the filament holder. Now we can connect these 2 pieces together, the bottom base and the gantry. Let's move it to the edge of the table so I can tighten the screws underneath. This printer and the CR10S Pro V2 have a base, so when you move it to the edge of the table, it will stand on the base and won't fall. The gantry and the base should maintain a perfect 90-degree angle. Tighten one side first, then flip it over and tighten the other side. Since we haven't gotten the BL touch yet, I will just install the Z-axis limit switch. A limit switch is used to tell the printer not to go over a certain point. The X and Y limit switches are pre-installed. Let's install this switch on the left side, and it should stay at the bottom. Okay, when we home the machine, it goes home, which means it will move the print head to the left and hit this limit switch, move the bed to the back and hit this limit switch, move the gantry all the way down to hit this limit switch, and now it's home. The current position is X0, Y0, Z0. Since the print volume is saved in the firmware, for example, this printer is 280 by 240 by 300, this will limit the travel of the maximum travel distance. For X, it can travel from 0 to 280. For Y, it can travel from 0 to 240. For Z, it can travel from 0 to 300. Next, install the spool holder, which should also be from Creality. One thing that isn't the best with this spool holder is that when you put a heavy roll of filament, it creates some friction with the spool, and that affects the extrusion. We can print a roll and use 2 bearings to replace this part using a model designed by HugoHuge, available to be downloaded from Thingiverse. I use this on all my printers. You can use it with bearings or without bearings. It's much better than the stock filament holder. The link is right below this video. To install the filament holder, just use the 2 loose screws and T-nuts. You need to put the T-nuts inside the aluminum extrusion. If you have bigger fingers, it may be easier to poke it with a wrench or a hex driver, then drop it like this. Mounted at the top, it should face this way, and the filament should hang at the back. Okay, the filament holder is now done. It's time to also mount the filament sensor at the top of the frame. A filament sensor is basically a limit switch. They work the same way. When there is filament passing through, it will hold down the button inside this sensor. So when the button is down, the printer prints normally. But when there is no filament, the button will be released, so the machine knows filament is running out and pauses the print. It works really simply, but it's very effective. We will mount it at the back side since the filament is hanging at the back. We can now mount this old school LCD screen to the frame. Using 2 M5x20 screws should be fine. Remember to connect the 2 cables for this screen, the EXP1 and EXP2. Finally, we can connect the rest of the cables. Just connect the cables to the motors and limit switches. Limit switch cables are 3-pin connectors, and motor cables are 6-pin connectors. We should have 4 cables for the motors, X, Y, Z. Since this is a dual Z-axis printer, we have 2 Z motors. There are 3 cables for the XYZ limit switches. Since we don't have a BL touch yet, we will also connect the Z-axis limit switch cable. Finally, connect the filament runout sensor cable. We are done with the assembly, but we need to check the wheels and belt tension to make sure they are tight, since sometimes they may loosen during transportation. The X and Y axis belts are both good. We also want to make sure the print head can move freely with a little bit of drag. Now it can move without using too much force. We can adjust it by turning this nut. We will do the same to the y-axis, which is the print bed, and adjust the nut underneath if it's necessary. Everything seems to be okay. Let's turn it on and see what happens, and hopefully it won't catch on fire. This is the main screen. Let's try to move all axes using Auto Home. This will check if all the axes are moving smoothly and all the limit switches are working. Auto Home is done. Now we will manually level the bed. To level the bed, first we need to disable the stepper motors so the XYZ axis can move freely. Some printers have leveling assistance by moving the nozzle to all 4 corners, but it seems this one doesn't have this feature, but no big deal. We can just move it by hand. Use a piece of paper or a post-it. Make sure the distance between the nozzle and the bed is the thickness of this paper. Adjust the height by turning these knobs. The perfect distance would be when the nozzle is close enough to the bed and is slightly scratching the paper. Do the same to all corners and the center of the bed. After that, we can install the filament. Let the filament pass through the sensor, then push the lever on the extruder and keep pushing the filament down. It will come out from the nozzle. The printer is now ready. We normally won't install the software that comes with a printer, since most of them are outdated versions of Cura. I will just use my own Cura to slice a model and do a test print. If you don't have one, you can download the latest version from ultimaker.com. First, we need to add a new printer. There's a profile made for the Sovol SV01. According to the manual, we only need to adjust the retraction settings and we are good to go. Normally, the retraction distance would be 5 mm, and the speed would be something around 50. For the direct extruder, it's recommended to set it to 3 and 50. Let's print some Sudoku tiles and see how they look. We can then compare them to those printed with the heavily modded Alfawise U30 Pro and the Creality CR10S Pro V2. To save some time, we will just print one set of numbers, 1 to 9. It looks like the nozzle is too close to the bed. The lines are being squeezed too much. You can see we have some elephant legs at the bottom. For now, let's just finish this print and we can adjust it later on. Okay, the results seem pretty good. I put a close-up here and you can judge which one looks better. I will also print a 20 mm test cube, which you can also compare to cubes printed by other printers. From left to right, Sovol SV01, Ender 3, Alfawise U30 Pro, and CR10S Pro V2. For the last test, I'm going to print 2 sets of M4 screws and nuts. I used to print that with the CR10S Pro V2. Let's see if the Sovol SV01 can print these tiny parts accurately. I would say the result is kind of unexpected. It prints even better. Now, let's talk about what this printer did well and where it could maybe improve. First, the direct extruder works pretty well. The dual Z-axis also provides a more stable movement and better print quality. It's super easy to assemble. I would also like to point out that some users said the filament sensor is blocking the Z-axis from going to 300 millimeters. I'm not sure if they mounted the filament sensor at the front. If so, it may limit the maximum height to 280 or 290, or it will bump this sensor. But after I installed this printer, I found it can go all the way to 310 millimeters. Another possible reason is that Sovol fixed this problem in the latest version of this printer. One of the things I think this printer can improve on is this 8-bit Creality control board. It's a noisy board because it has noisy stepper drivers. If they keep the 8-bit board and just upgrade to silent stepper drivers, it will become a silent board. But consider the basic model without BL Touch only costs $250. It can't include everything, so upgrades I will consider is spending $40 to install a 32-bit silence board, like the Big Tree Tech SKR Mini E3 2.0. The other thing is, now that the two Z-axes are working independently, Sovol could consider adding a belt to synchronize these two rods, like the Artillery Sidewinder X1. In fact, just adding 2 wheels and a belt would cost almost nothing, maybe a few dollars, but this could greatly improve the dual Z-axis system. Overall, I think this printer is worth the money it costs. I bought this when it was on sale at around $250. It comes with a larger than standard build volume, dual Z-axis and direct drive. I would definitely recommend it as your first 3D printer or second printer if you already have a basic entry-level one like the Ender 3. So that's it for this video. Thank you so much for watching. All information in this video is gathered from my personal experience with 3D printers. If there's anything incorrect or could be improved on, feel free to let us know in the comments so we can bring you better videos in the future. I would like to thank my brother Helios for being my tech support, cameraman, and video editor. If you like this video, please hit the like and subscribe button. See you later.